Alright, today we're going to be talking about how to prove two triangles are congruent. And you'll notice that we have here SSS and SAS. Those stand for, it's an acronym, and I'll show you what they stand for in just a moment. Alright, before we get started, we need to talk about some definitions, okay? The difference between an included side and a non-included side. So taking a look at this picture, I have two angles. The included side is this side right here. Notice it is included in between the group. So if you're having a conversation with three people, if one person is not in between the other two, it doesn't look like a group. Okay? Then you're actually having a two-person conversation and a third wheel. So an included side is a side that sits in between the two angles. Okay? Notice that this side is the only side that touches both angle 1 and angle 2. Alright, so now we need to look at the included angle. This angle sits in between the two sides. So it's similar to the included side, but this time the angle is the one that's in between. So this side, side 1, and side 2 are the only two sides that touch the same angle. So this angle must be the included side. So the question is, what does SSS stand for? It stands for side, side, side. We are allowed to prove that two triangles are congruent if they have three pairs of congruent sides. So notice in this picture, MN is congruent to QR. That's one pair. NP is congruent to RS. That's my second pair. And MP is congruent to QS, my third pair. Therefore, by the side, side, side congruence postulate, these two triangles are congruent. Remember, postulate is something we don't prove. It's something that we know to be true. We're going to be using these postulates in the future to prove different triangles are congruent. So keep that in mind. Alright, so here's our first example. It says that the markings on the diagram show that DE is congruent to, well, here are 3 tick marks, and the only other side that has 3 tick marks is JK. So we know that DE is congruent to JK. We know that something is congruent, excuse me, to KL. So that would be EF. Oops. Cannot draw an E today, guys. EF. There we go. And we also know that DF is congruent to JL. Oops, not an E there. So by the side, side, side congruence postulate, and you're okay to write side SSS, congruence postulate. I'm writing a little big here. You know that the two triangles are congruent. So we know that triangle DEF is congruent to triangle JKL. Now the order is very important here, okay? What we're looking at is that triangle DEF is congruent to JKL. So DE must be congruent to JK, and it is. EF must be congruent to KL, and it is. And then DF must be congruent to JL, and it is. Okay, so the order of the letters is very important. Alright, and the second postulate we're learning about today is the side angle side congruence postulate. If I have two pairs of congruent sides, 1 and 2, and their included angle is also congruent, okay, remember included angle means it sits in between the two lines. So this angle is the only angle that touches both side 1 and side 2. So that would be my included angle. So the side angle side congruence postulate says that these two triangles must be congruent. Alright, so let's work on this. Okay, we know that TY is congruent to what? XY. Okay, TY, XY. And then SY is congruent to WY. And the reason for that is it's given in the picture. And we know that angle 1 is congruent to angle 2 by the vertical angle theorem. So therefore, the two triangles must be congruent by the side angle side congruence postulate. So we are still using those proofs, okay, that we have talked about before. They are not going to go away. That's just typical geometry. Alright, so now it's our job to prove that these two triangles, FGT and RST, are congruent. So we're going to have to kind of start from scratch. I'm going to do a 2-column proof, and first off I'm going to say that FT is congruent to RT, and I know that GT is congruent to ST, and I know that angle FTG is congruent to angle RTS. And all of those reasons are given because looking at the picture I can see this side and this side are congruent, this side and this side are congruent, and their included angles are congruent. So, now that I know all those pieces of information, all I need to say is that triangle FGT is congruent to triangle RST, and the reason for that would be the side angle side congruence postulate. So probably the shortest proof ever, right guys? Alright, also, here we have a paragraph proof that they want us to fill in. It is our job to prove that triangle WYZ is congruent to ZWX. So it says the marks on the diagram show that WX is congruent to ZY, and also that WX is parallel to ZY. So by the alternate interior angle theorem, we can say that these two angles are congruent. So that would be angle XWZ and angle WZY. Alright, so by the reflexive property of congruence, remember the reflexive property says I am equal to myself. Okay, then WZ is congruent to WZ. Notice I have side angle side and then side angle side. So the two triangles must be congruent by the side angle side congruence postulate. Alright, what I'd like for you to do is pause and try these two. Basically, all I want to know is, do I have enough information to prove that these two triangles are congruent? If so, would I use side, 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 or side angle side? So pause and give it a shot. Alright, taking a look at A. Okay, we have two pairs of congruent sides and angle 1 and angle 2. Angle 1 and angle 2 are not vertical angles. Remember, vertical angles are made by two lines. Okay, I see 4 different lines here. 1, 2, 3, and 4. They all have their different slope. If I were to continue this line on, oops, I'll get my line tool for that one. If I were to continue this line on, notice it does not make vertical angles. There's a piece missing. So there is not enough information to solve or prove that the two triangles are congruent for part A. For part B, I can say that MG is congruent to itself by the reflexive property. So I can say, yes, these two triangles are congruent by the side, side, side congruence postulate. Alright, so in our next video, we will be talking about angle, side angle, and a couple of other ways to prove triangles are congruent. So make sure you understand this before we move on.